Alright, today we're going to continue with 2.1 and we're also going to start 2.2. So we're going to look a little bit more at quadratic functions and then we're also going to start to look more at polynomials of higher degree. And we want to understand everything we can about polynomials. So we're talking about degree, end behavior, possible number of real zeros, possible number of extrema, number of real zeros, the actual zeros, all of that fun stuff. So first let's do a little more practice with quadratics though. So if we have this problem, a textile manufacturer has a daily production cost of C equals 100,000 minus 110x plus 0.045x squared, where C is the total cost in dollars and x is the number of units produced. How many units should be produced each day to yield a minimum cost? So I want you to use your knowledge of quadratic functions and try to understand, well, what is this question actually asking me to do and how can I go about finding that answer. So pause the video and try to solve this problem. When you're ready, or if you get stuck, unpause it and we'll go through the solution. Okay, well, how do we go about this? Well, it can get kind of messy. We want to first put this into standard form because what we're actually trying to find is the vertex. So I rearrange the equation, so C equals 0.045x squared minus 110x plus 100,000. Now I'm going to complete the square. So I'm using my calculator to get these numbers, so you can type in your calculator as well. I try to do the minimal amount of rounding as possible. So first I divide everything by 0.045, so I get C over 0.045, and 100,000 divided by 0.045 is this value that I got here. It's a minus because I subtracted it over to the other side. 110 divided by 0.045 is 22,000 over 9. So now I completed the square. So to complete the square, I take half of this term and I square it. So again, I'm doing this on my calculator, so that's where I'm getting these numbers. So if I take half of this and I square it, I get 1493827.16. So I need to add that to both sides. When I combine this number here with the value that I got from completing the square, that's how I ended up with this 728,395.0617. It's a negative because this was a larger number than that. Now to actually complete the square, I know that it's going to always factor into this variable, this sign, so minus, and then half of this number. So half of 22,000 over 9 is 11,000 over 9. So that was not bad. Now I go ahead and finish. So I'm going to add the 728,395.067 to the other side, and at the same time I multiplied it by the 0.045. So that's how I went from the purple to the black, is I multiplied everything by 0.045 and I added this to the other side. So now this value became 32,777.777. It was a repeating infinite decimal, so I just rounded it off at 3 decimal places. So my vertex is 11,000 over 9, comma, 32,777.778. And what does that actually tell me? Well, this value here is the number of units that I should produce to get a minimum cost of this value. So that's why it's really important that we understand what do the variables actually represent in the problem so that we can answer the problem correctly. So if I type this into my calculator, it's approximately 1,222. So I'm going to say approximately 1,222 units should be produced each day to yield a minimum cost. Okay, so that was kind of a pain. The numbers are not nice and a lot of times they won't be. So another way in which we can find the vertex is to use our calculator. So I'm going to go ahead and pause the recording and put the equation into my calculator, so put the equation into your calculator as well. Okay, so now that you have this in here, one other thing, make sure you have turned off the plot from last time we used the calculator together, so shut that off, otherwise that's going to mess up your graph. Okay, now we're going to do zoom and fit. So this may or may not help, but the problem is I know that this is going to be a large quadratic, and pretending I had not gone through the work already, I don't know where this is going to show up at all. Okay, so this is all I see right now. Now this is where the calculator is not necessarily helpful. That if I haven't done the algebra work myself already, I'm kind of just guessing and checking as far as what I should be doing for setting my window to try to actually find that vertex. And what we ultimately want to do is second trace, and in this case minimum. If it was a upside down parabola, we would do maximum, and we would find the vertex. However, again, in this case it's going to be kind of a pain because we're pretending that I have no idea where it actually is. And so I would have to keep guessing and checking with my window. So I don't want to do that. So now we're going to look at, well, what is a shortcut to find the vertex? And so this shortcut is great for especially word problems like that. So the shortcut is that the vertex is the point opposite of b over 2a, comma, and then if we plug that back into the function, f of opposite of b over 2a. So now there's a couple of ways in which we can prove this to ourselves. One is we could complete the square. So if I have f of x equals ax squared plus bx plus c, I can divide everything by a and subtract c. So f of x over a minus c over a equals, I'll leave a little bit of room there, equals x squared plus b over a x. Complete the square, so I want to take half of the middle term and square it. So half of the middle term I know is b over 2a, so this is going to be plus b over 2a squared plus b over 2a squared. And now when I actually complete the square, this becomes f over x, or I'm sorry, f of x over a minus c over a plus b over 2a squared equals x plus b over 2a squared. And now I'm going to stop here because this is the part that I wanted to show you, that here, that's my h value. So h is going to be the opposite of b over 2a. And so that's how I end up with the vertex as the opposite of b over 2a. And then I can take that and plug it back into my ax squared plus bx plus c for x to find the y value. The other way in which you can prove this to yourself, which is kind of cool, is if we take f of x equals a times x minus h squared plus k, and if I multiply this out. So if we're to multiply this out, I'm going to end up with f of x equals ax squared minus 2ahx plus ah squared plus k. And so you might be asking yourself, well, how is this really helping me? Well, if I isolate some things, so that's my a, which I know, so that's a. This right here represents b, and this right here represents c. So I can set up a little equation here for b. I know that b equals negative 2ah, so if I solve for h equals opposite of b over 2a. Okay, so again, just two different ways in which I can prove to you, or you can prove to yourself, that the vertex is going to be the point opposite of b over 2a, comma, f of opposite b over 2a. So using that hint, or that shortcut, take a minute and find what is the vertex to this function here. So pause the video and come back when you're ready. Okay, So I just rewrote the function here, and h is going to be the opposite of b, so since b was negative 18, it's 18 over 2 times a is 2/3, which is 27 halves, or 13.5. So then k is going to be f of opposite of b over 2a. So I plug in 27 halves into the function, and I simplify, and I end up with negative 221 over 2, or negative 110.5. So my vertex is 27 halves, comma, negative 221 over 2. Okay, now we're going to talk a little bit more about polynomials. So we want to be able to identify some things about polynomials just from the function. So one thing we want to be able to identify is end behavior. What that's saying is what's happening in the graph as it goes to the extreme left or to the extreme right. Is it going up or down? So to do that, we have what we call the leading coefficient test. So if we draw this box here, we're going to separate it into 4 sections. And if this is the leading coefficient, and this is the degree, what we're looking at is the degree even or odd, and is the leading coefficient positive or negative. So if we think of some examples that we know, so for example, a quadratic with a positive leading coefficient. Well, what is the end behavior? So a quadratic is even with a positive leading coefficient. It's going to be a parabola going up and up. If it had a negative leading coefficient, it would go down and down. How about odd? So like a cubic. So if a cubic has a positive leading coefficient, it's going to go down left and up right, and up left and down right if it had a negative leading coefficient. So that's our leading coefficient test. Possible extrema. So extrema, what we're talking about are terms or maximums or minimums of a polynomial. So the number of possible extrema is going to be the degree minus 1. So again, think about a quadratic. A quadratic has a degree of 2. It has 1 term. Now again, this is possible, so it doesn't mean that they have to have that many turns. So, you know, a 5th degree polynomial does not have to have 4 turns, but at most it could have 4. The possible number of real zeros. So again, a key thing here is that we're using the word real and possible. So the possible number of real zeros is the degree. Okay, so I want you to take a minute and try to tell me everything you can about this polynomial. The degree, the terms, the end behavior, the possible number of extreme, the possible number of real zeros, the actual real zeros, and the y-intercept. So pause the video and come back when you're done. Okay, so hopefully you got that the degree was 5. That's our highest exponent. The number of terms, there are 3 terms. Remember, terms are separated by addition or subtraction, so I have 3 separate terms here. The end behavior, I have a positive leading coefficient and an odd degree, so it's going to be down, left, up, right. The possible number of extrema or terms, the degree is 5, so that's going to be 1 less, which is 4. The possible number of real zeros are 5, because that is the degree. What are the actual real zeros? Remember, real zeros are the same thing as x-intercepts, so we want to find the x-intercept. So if I set the function equal to 0 and I solve for x, I need a factor, so this I can first pull out a greatest common factor of x, and then x to the 4th plus x squared minus 6 becomes x squared plus 3 times x squared minus 2. Set each factor equal to 0. I get x equals 0 is one of my real zeros. X squared plus 3 equals 0 is going to give me complex zeros, so those are not real. And x squared minus 2 equals 0 is going to give me x equals plus or minus root 2. So my real zeros are x equals 0, x equals root 2, and x equals negative root 2. What is the y-intercept? Plug in 0 for x and I get 0. So the y-intercept is the point 0, 0. Okay, so just to recap, end behavior we can figure out from this little chart. Also, just kind of think of common polynomials that you know and what they look like. The possible number of extrema is the degree minus 1. The possible number of real zeros is the degree. And the vertex, don't forget the shortcut, is opposite of b over 2a to find the h value, and then plug that back into the function to find the k value. So it's f of opposite of b over 2a.